Gina Wilson worksheets that you have no previous from. Oh, sarcasm. Okay, let's go. So, if angle A is congruent to angle D, and side AB is congruent to side DE, and angle B is congruent to angle E, then triangle ABC is congruent to triangle DEF, and the reason is angle, side, angle. You have two angles that are congruent and the side that's in between them. Two angles that are congruent and the side that is in between them. All right. You guys know the drill. What should we do first on the proof? Yep. So SQ bisects RQT. So RQT is this angle. If SQ bisects that, that means that this angle and this angle are the same. So I'm drawing that on the picture. Okay. SQ also bisects RST, so that means that this angle and this angle are the same. So that whole thing was given information. And I drew it on the picture. Okay. They said RQS, so RQS is what I labeled right here. RQS is the same as TQS, and I already labeled that. And how did I know that I could label that? Yeah, definition of angle bisector. Okay. Definition of angle bisector. All right. RSQ, so this angle right here is congruent to TSQ. So these two angles are congruent. How was I able to label those? Definition of angle bisector. Okay. Without even looking at the proof, what would they have done next? Reflexive. They said that that line in between the two triangles has got to be the same as itself. That line is shared between the two triangles. So QS is congruent to QS. That's the reflexive property. And so the two triangles are congruent to each other by angle, side, angle. They have two angles that are the same and the side that is in between them. So congruent by angle, side, angle. How satisfying. Now, you guys have probably picked up on this, but anytime they give you information and they tell you that two lines are parallel, what does that automatically mean you're going to do at some point in the proof? You're going to look for corresponding angles, alternate interior angles, alternate exterior angles. You're going to look for something that has to do with two parallel lines and a transversal. So if they do something like this in the proof, you're going to revert back to the beginning of the unit when we learned about two parallel lines and a transversal. That's what they're going to bring into the problem, okay? So JK is parallel to LM. So JK, I always make sure that I extend those parallel lines so I can see what's going on. JK is parallel to LM. And then I think about like, oh, what could my transversal be? So can anyone see what the transversal should probably be from that? KL, probably that diagonal, okay. And so based off of that, can you guys tell where the angles are that are the same? Yeah, what are they? JLK, so this one, and, oh, actually, that's not even the angle that's being made, but I see what you're thinking. It's, yeah, JKL, it's this one, and what's the other one? Yeah, KLM. Okay, so those two. So those two are the same. And what's the reasoning? Alternate interior. Okay, so we've got that one. And then they said the other lines are parallel, so let's go ahead and draw those as parallel. Okay, so then they said JL is parallel to KM. So that's parallel. Here's our transversal. And then what angles do we get that time? That's where we get the JLK. Okay. So JLK, and then what else? MKL. Okay, and then what's the reason? Alternate interior. Okay, so our parallel lines, those are given. And then these two being congruent for both was alternate interior angles. All right. And then what do we have next? Reflexive, that line that's in between the two triangles is the same. Reflexive property. Okay. And so the two triangles are congruent to each other by angle, side, angle. Okay. All right, go ahead and turn the page. This next one is going to be part of your practice assignment, not your notes. This is a practice problem, okay? So I'm going to skip that one. We're not going to do that as notes. Oh, dang, maybe we should, though, because it's not filled in at all. No, I feel like you can do it. Okay, let's do the next one, though. Okay. Angle, side. All right, so we got angle A is congruent to angle D. Angle B is congruent to angle E. And BC is congruent to EF. So same information, we still have two angles and a side that are congruent, but this time the side is not in between them. This time the two angles are next to each other and the side is not in between, it's on the other side of the angles. So if this is the case, then triangle ABC is congruent to triangle DEF by angle, side. All right, how do we start the proof? Write down the given. So we've got two things for given. We got YZ bisects W, and we have angle YWZ is congruent to angle YXZ. Okay. I guess I could write given. And I need to draw that information in the picture. So YZ is that middle line. It bisects WYX. So this angle and this angle are the same. YWZ is congruent to YXZ. Okay. So from the first part, YZ bisects WYZ, those two angles that we drew, we have to write that down. So what should I write for number 3? Before that, I'm going to write that these two angles are the same. X, Y, Z, and what's my reason? Yep, definition of angle bisector. Okay, and then Jack, what were you saying?
I was saying that YZ equals line, definition of a bisect.
And it would actually be YZ is congruent to YZ. And that's because angle Y is the same as angle Y in each triangle. The Y is the same angle. And that's the reflexive property. Okay. And so what should we write down here? Because of angle side. Boom. Got it. All right, next page. Right. Angle ABC is congruent to angle CED. ABC, CED. Oops. ABC, CED. AB is parallel to CE. What does it tell us as soon as they say they're parallel? Yeah, potentially corresponding, potentially alternate interior angles, something like that. So AB, just drawing my parallel lines really long here. And you can think of it kind of using a little bit of common sense here, is that there's some angle relationships you don't even have to think about because we're thinking about stuff that's going to be inside of the triangle. So I'm looking for a transversal that is either going to give me this angle and this angle, or I'm looking for a transversal that's going to give me this angle and this angle. Does that make sense? So I'm thinking about two parallel lines and a transversal, yes, but I'm also thinking in terms of I've got two triangles and I need some sort of angle to be the same because I'm trying to prove two triangles are the same. So what line do you guys think is the transversal in this situation? Yeah, probably AC or AD, which is the same line. Okay, so I'm going to make that the transversal. I'm going to draw it really long. There's my transversal. Okay, we're going to come back to that in a second. C is the midpoint of AD. Okay, what does that give us? C is the midpoint of AD. So C is the middle, so what does that tell us? Okay, so these are the same length. Okay, so that was given, given, given. Now I labeled that these two were congruent, so I should go ahead and write that down. AC is congruent to CD. And what's my reasoning? Definition of a midpoint. Okay. All right, from our two parallel lines and our transversal, can you guys see what angle they are trying to say is the same? Okay, BAC and an angle ECD, and what's the reasoning? Corresponding angles. Very good. So if this is where they cross, it's like 1, 2, 3, 4. I can see this is kind of like the bottom right side. 1, 2, 3, 4. This is kind of like the bottom right side. So they're corresponding angles. They're in the same spot. Okay. And then what is our last line going to say? Okay. Oh, yeah, you're right. That's a typo. We found a typo. C and CED. I didn't even notice.
Hey, we're not supposed to prove it if there's a typo.
Oh. Don't worry, guys. It's Gina's problem, not mine. All right. And then what's the... And then this isn't even algebra. This is geometry. That's probably why she messed up. All right. And then what's our reasoning here? Angle, angle, side. All right. I didn't even catch that yesterday. Okay. I'm going to leave the next one for you to do. This is practice. Let's do number 7. Yes. Yes, ma'am. Huh? Yeah, that's fine. Yep. All right, number 7. Two parallel lines. LG is parallel to JM. So it is my opinion that the two parallel lines in a transversal are the hardest part of these proofs. Would you guys agree? No? Well, I was going to say, are they getting easier? Yeah? Okay. LG is parallel to JM. Okay. This is an interesting proof. You'll see in a minute why this is an interesting proof. H is the midpoint of LM. Okay, so if H is the midpoint of LM, what does that give us? Yeah. So we got given, given. Okay, I like how you could already tell that, like, what was kind of corresponding here. So LH, we said, is congruent to MH. Now, if you wrote, let's say you wrote LH, HM are congruent, which we can kind of guess if you, so honor students, I think, can see this a little bit better than maybe non-honor students can. But let's say you were a non-honor student and you wrote LH, and then you wrote HM, and then they ended up not being in the right order. You can always go back and change it once you realize that you put the wrong thing corresponding together. Does that make sense? In fact, you probably should at the very end of your proof kind of look back and make sure you put things in corresponding order. Because as you're doing the proof, sometimes you find like you get some more clarity as you notice what corresponds. Does that make sense? When you know, it's easy to know these two sides correspond in the beginning, but as far as knowing exactly all the letters that correspond, we're not quite there yet. Does that make sense? So we know in the proof that those two sides correspond, but the rest of it is kind of hard to tell so far. Okay, this proof is interesting because there's actually two different triangle congruences that could prove it. So what do you see in the picture that we can work with? LGH, MJH. So you're saying you're using this as your transversal? Okay. So you're saying this and this. Okay, so angle LGH is congruent to MJH. Okay, so this was definition of midpoint. And this is alternate interior angles. Okay. All right. Yeah, so you have two options now. You can do the other transversal. You guys see that? And you can do those alternate interior angles, and then you're going to get angle, angle, side. Does everyone see that? Angle, angle, side. Okay. Or you can do the vertical angle, and if you had started with that alternate interior angle, then you could have done angle, side, angle. You guys see that? So this is a proof where, depending on somebody's approach to the proof, they could have done an angle, side, angle proof, or they could have done an angle, angle, side proof, depending on their approach. The goal of the proof is to show the two triangles are congruent. So you're right either way. Because they gave us those two parallel lines, and because we have the vertical angles, we have lots of different ways of proving these two triangles are the same, and there's not one answer that is more right than the other. We have different approaches, and we can win regardless, okay? So do you guys want to do the vertical angles, or do you want to do the other alternate interior? What would you prefer? Alternate interior? Okay, so let's get our other vertical angles, or our other alternate interior kind of drawn in here. So we got this transversal, and that means our other alternate interior angles are like this. Okay, so how do we label the other alternate interior? And JMH, okay. Alternate interior angles. So triangle LGH is congruent to triangle MJH. And based off the way that we chose to do it, we got angle, angle, side, although that's not the only possible way to do it. All right, last one. Now, I know the markings look like angle, side, side, but they're not. This is a specific exception to that rule. It has to do with 90-degree triangles, those right triangles. And so this one is called hypotenuse leg. So hypotenuse leg you can use anytime you have a 90-degree triangle. It is the only time you have angle, side, side. Angle, side, side does not work for other triangles, only 90-degree triangles, right triangles. I know, they're breaking all the rules. There's a joke in here somewhere, but I'm trying not to record myself saying anything inappropriate. All right, here we go. So if you have, so you have to start off with them saying there is a right triangle. So if they don't say there's a right triangle, you cannot use hypotenuse leg. Okay, they have to say there's a right triangle first. Then, if you have a right triangle, you can say if you have a hypotenuse, so if BC is congruent to EF and AB is congruent to DE, so if you have a hypotenuse and then you have a leg that are the same, then triangle ABC is congruent to triangle DEF, and the reason is hypotenuse leg. HL. So it only works in right triangles. And it's not leg, it's hypotenuse leg. So one of the sides has to be the longest side of the right triangle. The longest side of the right triangle is always across from the 90-degree angle, okay? All right, so it says here exactly what we need it to say, that the two triangles are right triangles. You can tell there's the 90-degree angle drawn in for you. Then it says ML is congruent to MN. Let's draw that, ML, MN. So the hypotenuse is the same. And both of those are given. And then what other information do we have? What else do we have? MP is congruent to itself by the reflexive property. And so because of those two things, we have right triangles, we have hypotenuse leg, therefore, HL. The two triangles are congruent from HL. Boom, done. All right, we're going to do number 2 together because, in my opinion, it is a poorly written proof. So I want to address this. I don't like this one. I went over to Miss Lopez yesterday and I said, Miss Lopez, I don't like this proof. And she said, I know, I don't either. And I said, good, we're on the same page. All right, number 2, triangle WVX and triangle YZX are right. I'm just going to write RT triangles. That's given. WV is congruent to YZ. Let's go ahead and label that. WV is congruent to YZ. And X is, I wrote id. X is the midpoint of WY. So if X is the midpoint of WY, then these two are congruent. Okay, so if X is the midpoint, then how do we write that these two are congruent? WX is congruent to YX. Okay, so this was given, and then what was this one? Definition of midpoint. Okay, can anyone maybe tell me why I did not like this proof? They don't say what the right angle is. So if I'm playing devil's advocate, I'm like, this is the right angle. I'm going to say this is the right angle. And this is a picture that's not drawn to scale, and they gave me 2 legs. That's what I'm going to say. Because they didn't tell me what the right angle was. I think this is a poorly written proof. I don't like this one. So write a note to yourself. This is a proof. They didn't say what the right angle was. You have to assume that the right angle is the angle over here that kind of looks like a 90-degree angle. You have to assume that for this proof to work. That is not a good proof, okay? This is a poorly written proof. Well, poorly drawn, really, the visual's bad. This is a poorly drawn proof.
So wait, if it, let's say
Or
they said like angle WEX and angle YEX are right angles.
they either have to draw the right angle or show you where it is. They have to do something to show you where it is, but that's, in my opinion, that this proof should not have been done this way. So for this proof to work, it has to have the 90-degree angle there, because in a proof, you shouldn't be able to play devil's advocate, and I can. I can go in here and say, oh, what if those two are legs? This proof doesn't stand up. Because if the two legs are congruent to each other, that's not enough information to say that the two triangles are congruent. And they don't give you enough information. They don't say, oh, that's the hypotenuse. If they said that these two are congruent and those two are each of the hypotenuses, hypoteni? I don't know what the plural of hypotenuse is. But so I would have been okay with it if they said it was the hypotenuse. I would have been okay with it if they labeled the right angle, or if they said where the right angle was, but they didn't do any of that. So devil's advocate says, I can say that both of these are legs, and that the picture is just not drawn to scale, because it's common practice in geometry for pictures to not be drawn to scale. That's why I don't like this proof. I knew what they meant, but math should never be based off, oh, I knew what you meant. That is bad math. So I do not like this problem. Ms. Lopez doesn't like it either, for the same reason. It's not very good. I wanted to point out to you guys, because you're honor students, and I figured that some of you guys would pick up on that we could play devil's advocate with this, and we shouldn't be able to in a proof. That this is not a good one. Okay, so I wanted you guys to notice that's something that I agree with you on. Okay, so let's go ahead and finish the proof now that we've made the drawing better, now that we've fixed the drawing the way it should have been done. How do we finish the proof? Triangle WVX is congruent to triangle YZX. And what's our reason? HL, now that we fixed it. Okay, so you've got two more to finish in here. If you look in your booklet, you've got some proofs in your booklet to do. So today we're going to do the angle side pages, the angle side angle pages, and the hypotenuse leg pages. And then I got a worksheet for you also. Ms. Rice, it's like you really want us to do some proofs. I do. I got some proofs for you guys. Huh? So booklet 5 through 10. The ones you were doing in here were 3 and 6. So booklet 5 through page 5 through 10. Finish number 3 and 6 from the notes, and then I'm handing out a worksheet.